is Pavel Prichodko, and I am the head of data analysis group at DataAdvance. In this video, I'll tell you about sample viewer functionality we developed in pSeven version 6. The video will consist of two parts. In the first part, I'll give you a quick overview on what sample viewer is. And in the second part, I will solve a small data analysis problem with it. Okay, let's start the demo. To show you what sample viewer can do, I will use small problem we once solved in DataAdvance. I already created a project in pSeven with the data we will work with. Now I go to Analyze tab, and first of all, I import the data to Data Series pane. Okay, I select a file with the data, click Select. Seems import went well. If it didn't, there are various options to handle it in Import Wizard. Look, the file has 14 inputs, from x1 to x14, and one output f. We click Import, and you can see your sample in Data Series panel. There are 70 points in the sample. We select the data we have and open Sample Viewer. Currently, Sample Viewer consists of 4 tabs. The first one, called Data, it just shows you the table with the data you loaded. The second one, Statistics, shows you some general statistics about your sample as a whole, like other duplicate dimensions or points, and about each dimension in particular, like its bounds, number of unique values, and so on. The third one, Scatter Matrix, allows you to check various correlations you have in your data. And the last one, called Approximation, allows you to see if one of the dimensions you loaded is actually a function of others. When we designed Sample Viewer, we decided to have different views on the data to exist in one window to allow user to quickly switch between different perspectives of his data, and to make things like joint filtering simple. So, like you notice some outlier in Statistics tab, configure your filter for this dimension to remove this outlier and see how it affects correlations on Scatter Matrix tab. Now let's return to our example. When you get a new sample, it's usually a good idea to open Statistics tab first to check if everything is okay with your data. Here you can check for duplicates, not number values, and see if there are some strange unexpected values in your data. In particular, one thing a person can note about the data set we look at is that there are actually quite few unique values for each output, and all values of output are unique. This suggests that our data probably has some special structure. Let's check. One way you can look at your data is to go to Data tab, select dimensions you are interested in, and open plot, show them. Let's open through the scatter plot. Okay, let's make point bigger and brighter. So let's make them red and big. Okay, now it's better. It seems that most of the points lie on the border of input domain, and one point is somewhere around center. Okay. Let's switch dimensions we're looking at. Same picture. Okay. The other way you can found layout of your points was opening scatter matrix tab and checking scatter plot we have for each pair of dimensions. You can enlarge these plots if you want, if they are too small for you. In addition to scatter, this tab shows matrix of pairwise correlations and ordered list with same correlations to the right. We have various types of correlations implemented in pSeven, which allows you to check for linear, monotonic, and even general types of dependencies. Currently, we look at Pearson correlation, which checks if there is linear dependency between pair of variables. Color indicate that this dependency appears to be significant. And color also indicates its sign. It's negative correlation here. Okay, now let's try to build linear approximation using all the data, all the inputs we have. Okay, we already built one. The scatter plot to the right shows f-values that our models predict versus the actual values of f at these points. If the prediction is perfect, all dots would lie on this black line. As you can see, currently the prediction is far from perfect. Actually, the model catches no dependency at all, always giving same almost constant answer. As alternative to looking at the picture to the right, you can also check error table to the left. It gives model accuracy on train set and accuracy estimated with cross-validation. This error metric, relative residual mean squared error, tells which fraction of output variance the model does not explain. Value of 1 means that the model cannot explain anything, which we already observed on the plot to the right. Below you can see feature importances computing using the model, but please note that they are as good as our model is. So, as our model currently does not explain anything in the data, you should not trust this either. Okay, let's return to scatter matrix. One may have already noticed that there is significant correlation between output and two inputs, x2 and x5. Let's rebuild our linear model using only these two inputs. Okay, it's still not perfect, but it's definitely better. Now it explains about 25% of output variance, and you can see that scatter plot is also better. Okay, let's try to improve our model further. One problem you have when you explore dependencies in multivariate problems is that strong effects of some variables can screen weaker effects of other variables, which makes them much harder to detect. To negate this, we have a partial correlations implemented. They subtract effects of other variables when checking for dependency between pair of variables. Let's try partial Pearson correlations. Okay, now we see much more details in the data. These two we already spotted, but there are some more inputs our output appears to depend on. So it's x3, x6, x12, x13 and x14. Okay, let's add them to the model. x3, x6, x20, 13 and 14. Okay, it seems so accuracy improved quite a bit. Now our model explains about 60% of output variance and actually catch something. You see the median error is 8% and for 90% of points the error is below 46%, which is still not perfect, but it's already something. If simple linear model is not enough, and to check if model is enough or not, you may look at train accuracy, because it's not good accuracy measure in general, because it usually overestimates model accuracy. But if even train accuracy is good, then probably your model is too simple. You can try more complex models. For instance, you may try quadratic approximation, or even use more advanced option from macros library that would allow you to build more complex models. It's also worth adding that all pictures in tables you got in sample viewer can be saved to disk and used in reports and presentations. Well, this covers the basics of sample viewer usage. If you want to know more details, please visit our website or write us. Thank you for your time and see you at Data Advance.